Okay, so I think we are ready to go here, Amit. And as I'm talking, I'll allow for some time. You still set up your environment if you're following along the links there as well. So first of all, thank you everybody for joining. I really appreciate you participating in this session that we have. If you're located in Pacific Standard Time, you're probably in the morning and getting your day started. Or if you're in the East Coast, where I am located in Toronto, Canada, you're probably on your lunch. So we appreciate you joining us. I do want to thank as well Treeverse and lakeFS, Amit, who will be delivering this roughly 1 hour presentation. We'll see if we go over. But I do appreciate Amit, who's been willing to support our community here, offer some great information. And I'll just start by maybe taking a minute to introduce Amit. He heads the solution architecture group at Treeverse. Treeverse, if you're not familiar, is the company behind lakeFS. It's an open source platform that delivers a Git-like experience to object storage-based data lakes. And Amit, well, I'm excited for having the opportunity to introduce him, but also to provide an opportunity for you to ask any questions that you might have, because he comes with 30 years experience as a technology professional, working with Fortune 100 companies as well as startups. A lot of experience designing and implementing technical solutions, specifically around complex business problems. Also as an entrepreneur, he launched a cloud offering to provide data warehouse as a service. He holds a master's certificate in project management from George Washington University and a bachelor's degree in computer science and technology from IIT, that's the Indian Institute of Technology in India. He's the inventor of a patent as well for system and method for managing and controlling data. So I leave you in good hands with Amit. My parting words are thank you. If you do find yourself local in the Toronto area, we will be joining tomorrow night at the RBC Water Park Place for our Generative AI Micro Summit in the evening. So feel free to check out torontomachineLearning.com, where you'll find some information about the event tomorrow. I also want to extend an invite. And as well, you'll find the follow-up to this session on the website afterwards. So you'll have a copy of the video recordings, so you can go back and rewatch anything you may have missed as we go along. Last parting words as well is feel free, Amit has graciously said, feel free to put any questions you might have in the chat. And at an appropriate time when he has a moment to catch the chat questions, you can go back over those. But please, I encourage you to ask lots of questions. I think the benefit and what you take out of these sessions is directly proportionate to your willingness to ask questions and sort of put yourself out. I know that there's a lot of imposter syndrome when it comes to the generative AI and the data science and the AI fields. It's natural. But that being said, I do hope you are willing to ask questions and engage, because it comes with a wealth of experience and knowledge. With that being said, thank you very much, and I will turn it over to Amit.
Thank you, Dave. Thanks for good introduction, and thank you guys who joined this session. So today it's more about the workshop. I'll walk through a kind of sample demo kind of environment. If you want, you can run this workshop on your own. So I have provided some links here. So there are two requirements here. One is the cloning a sample repository, where we provide a sample notebook to run this demo. So what you can do is clone the repository. You can go to this link here. I also put this link on the chat, or you can scan this QR code and go to that to our sample repository. And it also, the repository README page also provides all the instructions, but instructions are here also. You can clone this repository on your laptop and then build this demo environment by running this Docker compose command. So the requirement is you need to have a Git installed as well as Docker installed on your laptop. If you don't have currently, you can do it later also. We'll provide all the instruction and everything, and you can just follow me during this presentation, during the workshop about this demo. So that's the one requirement for the repository to clone and build your container. It takes about 5 to 10 minutes. So if you want, you can start that process while I'll go through some slides, and then we'll go into the real workshop or demo. Another requirement is I'm going to use another tool called lakeFS, which is an open source product. You can sign up for lakeFS in the cloud. It's a free 30-day trial offering, so you can sign up on lakefs.cloud. Or if you want to run lakeFS locally, when you are building the container along with the sample repository, you can also install the lakeFS locally also using this command here by Docker Composer. So you can either sign up for lakeFS in the cloud, or you can set up your lakeFS environment locally on your laptop in a container environment. So that's pretty much to start. Let's get into what I'm going to do next is talk about what I'm going to show in the workshop and do in the workshop. So I have a couple of slides to walk through, and then we'll go into the real workshop. Okay, so let's get started. So let's look into some of the things, LLM challenges. LLM is becoming very popular nowadays. A lot of companies are investing time and effort and money into implementing this application based on LLM. But there are lots of challenges, and there are some of the challenges which I'm going to talk about today, not all, but some of those things are like for example, if you're using OpenAI or any kind of LLM in models, you need to understand their API specifics. Like in this case, for example, for OpenAI, you need to understand their endpoints, the protocol that they use, how to authenticate, and different types of APIs that they have. So how to use those APIs. So you need to understand all those API specifics regarding those LLM models. And the next one is how to communicate with those models. This is a sample workflow or flow I found online, like how you communicate with the model. It gets very complicated, like how you pass the embeddings, how you handle the vector embeddings, and how do you communicate, how do you pass all the information that model needs. So that's also a very challenging part. And the next thing is also you have to apply your domain knowledge in your business. So you cannot just take a sample, a demo, or like a hello world example and implement in your business environment. You need to apply your domain knowledge to implementing or building a LLM application. So that's where you might do some fine tuning of the model. You might do prompt engineering. Another technique to use it, retrieval augmented generation, which is called RAG, which is basically applying the context or recent data context to your input data. So those are different techniques you have to utilize to apply the domain knowledge to your LLM applications. And another challenge is handling multiple data sources. Data might be coming from different sources, real-time, historical data. You might have big volume or velocity of data, and it might be stored in different locations, like in the cloud or in your on-prem. So you need to handle all different types of data sources to feed into that model. The more data you have, the better results you get from these models. And the next challenge comes into like how you do the versioning, not just the data part, but how do you version the model and as well as the code. So you want to version both data model and code. And the next challenge comes into, which is main challenge is the reproducibility. Can you take one code or one model and run this in your development environment, test environment, and production environment, producing the same result? And also, can you go back in the history, how the model performed like 6 months back? And can I rerun with the data which was at 6 months back and try to reproduce the problem? So that's also very big challenge. And a lot of things you can implement, you can build a solution on your own. It takes time and it's very challenging and very complex to build a lot of things on your own. So that's where LangChain come into the play. So LangChain solves a lot of these challenges. It's a framework to build your LLM applications. And it kind of provides a chain kind of construct to step all those things together, like building a data pipeline you build where you can do things in a step-by-step. Similarly, for building your application, LLM application, you can build different steps in a chain that helps to kind of quickly implement and simplify to build your applications. And LangChain provides a lot of benefits, a lot of features, like where you can stitch together or step through different, not just single LLM model, but multiple LLM models also, if you want to use. And it helps in the communication with the model. So it provides the common interaction with the model and how to easily communicate with the model. And you'll see in the workshop also in the demo, like it's very few lines of code to communicate with the model by using LangChain. And also LangChain also provides the prompts library to parameterize common prompts, as well as it provides the output parsers, so you can do post-processing easier. And on the data connection and retrieval side, it's provide the integration with all the cloud storage, as well as if you want to implement the RAG pattern, it provides the library to handle that, to help in the implementing retrieval augmented generation pattern, as well as it provides a kind of a document kind of flow to pass the information from one step to another. So if you are putting all those chains together and you want to pass the information from one step to another, you can pass it through a document object in LangChain. And it also does provide the integration with different vector stores. Vector stores can be utilized for search purpose, for example, similarity search. So that's also is provided, integration is provided with the LangChain. And next thing is also provides the agent. So agent module lets LLMs decide the best step or action to take to solve a problem. So what LangChain provides is orchestration of a series of complex commands to LLM and other tools to get them to respond to specific questions and provide the solution for those questions or answers to those questions. And LangChain also provides the chat memory, so you can store all the interaction, all the chats you have in in-memory store or in NoSQL store, so you can apply the context to the next question. So you can take the chat memory and take the historical or previous question or answer for the previous questions and apply that to the next question. So that provides you better kind of output or more contextual application. So those are some of the benefits, advantages that LangChain provides to solve those challenges that people face with LLM. And also, as I mentioned earlier, LangChain provides the way to pass the information is through document object. So you can load any kind of document or any kind of structured and unstructured data to LangChain in a document format. And so whether it can be a YouTube video, it can be any Word document or any PDF document. So what lakeFS provides on top is the version controlling those documents. So let's say the information changes over time. You're building some application for your business application. Like, for example, let's say you have a pricing and people can check the pricing by asking questions, and the pricing information changes over time. Or if you're building a support application, you have a document, your product documentation, which is changing over time, and you want to version control that. So you can go back and see what was the information 6 months back, for example. Let's say, what was your pricing 6 months back? And when people ask about the pricing, what kind of responses they've got 6 months back versus now, because the pricing changes over time. Same on the support side. Let's say your documentation is changing over time. So you can version control everything using lakeFS. And lakeFS and LangChain work very easily together. I'll show that in the workshop. And so let's quickly talk about the lakeFS, what lakeFS brings into the picture here. So we talk about LangChain, how it simplifies the building the LLM application. And while lakeFS simplifies the version controlling your data set, as well as reproducibility challenges. So lakeFS sits on top of object stores. So if you're storing data on S3 or Azure Blob or Google GCS or any on-prem storage, which is a more S3 compatible object store like MinIO or Lustre or Dell ECS, lakeFS sits on top of that to version control all the information in your object store. And lakeFS is more, think about Git for data. So similar to what Git is for the version controlling your software, lakeFS does the version control of your data, providing the similar kind of things, like you can create the branch from your data store. You can revert back your changes. You can merge your changes into production branch. Everything you can do through an API, and your front-end tools communicate via lakeFS or directly can go to the object store. And the way it works is when you, let's say, for example, your data is stored in S3, you might have a bucket in S3, and within the bucket you have, excuse me, you have path where your files are stored or data is stored. When you use lakeFS, the only addition you do is like you specify your bucket or the repository name, and then reference to any branch or any commit or tag. So you can create the branch within lakeFS and add that in your path to access your objects. So let's say you create a branch for version 1. And so when you're accessing your data, you can specify the repository name / the version 1 / the path of the file or path where your data is stored. So that's how the only change you have to do when you lakeFS. You specify the reference or the branch name or the commit ID when you commit any changes in your data object store, or the tag if you create a tag in lakeFS. So those things you specify, add that to commit to access your data. And the way it works with the LangChain Document Loader, like we provide, lakeFS provides its own library for document loader for lakeFS. So simple thing you do is you use lakeFS library, Python library, and specify the repository name, which you create in lakeFS, and the reference, which is basically branch or version or commit or tag, and the path, and then just load the document into LangChain. So that's an additional like 4 lines of code you will add into passing the information from lakeFS to LangChain, so that way you can version control everything, any documents you are passing to LangChain. So how lakeFS works, like internally, we maintain the pointers to all the objects. So let's say you have a bucket which lakeFS is managing, and you commit your data into that lakeFS repository. So each commit is just the pointers to the files stored in your bucket. So lakeFS doesn't store the data. Data is stored in your object store in your bucket. lakeFS just has a pointers to those files for each individual commit. So let's say you have a main production branch or main production data set, and then you make commit, or you add your data into the repository and you commit, and the commit will have all the pointers to those files. So over time, when you create another commit, let's say you get new data set. In this case, let's say I delete a file and add a new file. As you know, the object store is immutable, so you cannot update any file. You basically delete file and add a new file. So let's say in the new commit, you delete a file and bring some new file. So then that commit will point to the new file and not instead of a deleted file. So the old commit will have pointers to all the previous files, and the new commit will have the pointers to the new file or any changes that happen in that commit. So that way we maintain all the history. Another question people ask is, like, if I have too much information, this information will accumulate in my bucket and it will grow over time. So what we have a process called in lakeFS called garbage collection, where you can specify or your data retention policy for different branches. Let's say for production data, you want to delete the historical data after a year or 2 years. So you can define your policy based on different types of branches. Let's say you have dev branch or your test branch. For that, you might have less retention policy, like less data retention, while your production data you can retain for longer, and the garbage collection process will clean up delete all the historical on data set, which is not in use further. So you don't have to worry about that if that data will continue to grow or the object store will continue to grow. So that's how internally lakeFS works. So when you create a new branch, let's say you create a new test environment or dev environment, when you create a new isolated environment, it is a millisecond operation, even if you have terabytes or petabytes of data, because we just create another commit pointing to the same objects at that time. So creating a new environment, testing environment, is a very millisecond operation, and it doesn't impact your production branch. So if you make any changes in your test environment, it's going to have those changes only in that test branch, not impacting your production environment. And also, it helps in the ML reproducibility side. Like you can go back to your previous commits. So let's say you have a model you're running with the current data set, but how you want to see how that same model performed 6 months back. And you want to run that model against your data going 6 months back. So you can go back to your previous commit and run the model against that. Only thing is when you access the data, you specify the commit ID or the tag ID at that time when you committed your data set. So that's how lakeFS works internally. Now let's go into more on the workshop and the demo. So before I do that, again, I'm sharing these links here. So if you want to set up your own environment, you can follow this link. So let me just look at the questions if there are any. And just 1 second. So somebody asked, would like to know how lakeFS compares and contrasts with Delta Lake. So lakeFS is complementary to Delta Lake, and we have very good integration or tight integration with Delta Lake. Delta Lake also has a time travel capability where you can go back in the time, but the time travel works for a single table, while lakeFS works across all the tables. If you create, let's say, thousands of Delta tables, and when you go back a previous commit or roll back any previous commit, it applies to all the table, not just a single table. So we do kind of time travel for all the table at the instant of time. And lakeFS works for structured, unstructured, all kinds of data set, anything you store in the object store. So that's the difference with between lakeFS and Delta Lake. And lakeFS is complementary to Delta Lake. We also provide Delta diff capability. So let's say you have 2 different commits or 2 different branches. You want to do the difference between those 2 commits. We will tell you what are the changes happen in your tables across all the tables between those 2 commits. So what rows were inserted, what rows were deleted, all that detailed diff will provide difference will provide via lakeFS. So it's a lakeFS is complementary to Delta Lake. Okay, let me see if there are any other questions. Would you please put the links of the first slide in the chat? I think I put that in the chat initially. Let me put that again. So this is the link for the sample repository. You can click on that link, go to the sample repository. You can clone that, and the instructions are also here, and also they're on our sample repository page. And also, let me just type in the cloud link. Just 1 second. So with lakeFS Cloud, you can register online and you get 30-day free trial on lakeFS Cloud. With lakeFS Cloud, we also provide the object store along with that. So you don't need to bring your own S3 bucket or any object store you want to use. We provide that with lakeFS Cloud. So you can utilize that too. And let me see if there are any other questions. So 1 second. I think that's it so far. If I missed any question, you can please ask again. It's a long list of chats here. So if I missed anything, let me know. Okay, so let me now go into the real workshop and the demo. Let me hide my Zoom controls here. Okay, so as I mentioned earlier, so you just need this sample repository. So let's go there. So I'll walk through everything, what to set up this environment in your laptop. and you can run this demo or workshop on your own. So we have all the instructions here. This is our sample repo, which provides a notebook to run this workshop. So you will clone the repository, sample repository, so which I already cloned. It takes about less than a minute to clone everything, and then build the environment. So let me just go to that. Let me open my terminal here and go to that folder. I already cloned my repo. And now let's run this Docker Compose up. So to build the container, I already built it once. So when you do it for the first time, it might take 5 to 10 minutes, depending upon your network bandwidth, to download all the libraries. So now I have this container running. So let's quickly check here. So this is my container, which includes the notebook to run this demo, as I mentioned earlier. And then the next requirement is to sign up for the lakeFS cloud. So let's do that. I already signed up lakeFS cloud yesterday, but if you are doing it now, just provide your email information, name and the password, and just sign up. And once you sign up, you will also receive an email to verify your email address. So you'll receive an email like this. Just click on this link here to verify your email address so you can access the lakeFS cloud. And I already signed up yesterday, so let me just log into my lakeFS environment, lakeFS cloud. Okay, so when you sign up, for lakeFS, we provide a cluster, a lakeFS cluster for you. So you can spin up a cluster in different region also, but by default, we provide in the US East 1 region. And this is my lakeFS cluster environment here. If you want, you can run lakeFS locally also. If you don't want to sign up for the lakeFS cloud, you can run locally. And if you want to run that lakeFS container locally, when you build this sample environment or image or container, you run this command to run this demo container as well as lakeFS container both on your local laptop. So if you don't want to sign up for lakeFS cloud. Okay, so now I have my container running, which has sample environment. So let me close this. I signed up for lakeFS cloud. And now let's go into lakeFS server. So here you can click on this link and it will straight away take you to the lakeFS environment. So here, as I mentioned earlier, when you sign up, we provide a sample repository and we also provide an object store. In this case, we provide an S3 bucket. So you can do your testing. You don't have to bring your own object store. We provide it for you so you can do any testing you want to do. And if you want to change to point it to your S3 bucket, you can do through a setup here. So if you go into onboarding, you can set up here, you can pick your cloud vendor and pick your region, and then you provide your own S3 bucket to connect to your own environment. So I will not go through that setup environment. Let's stick to the workshop today. So this is just the sample repo. This is UI for lakeFS, very similar to like Git interface. So here you can create the repositories, again pointing to your storage namespace. So, and as I mentioned earlier, we provide this S3 bucket here. And also in the administration, I'll walk through that, like different options available, like role-based access controls. So if you can define your users and groups and policies, which are very similar to IAM policies. So you can control who can access your data. Okay, so let's go back here. So now we got this environment set up. We have the sample container running. We have the lakeFS environment. So let's now look into the demo or workshop. So if you go back to the container here, running container, this is the port I'm using for running the Jupyter notebook or Jupyter UI. So just click on this port. It will take you to the Jupyter lab. And in this, we have this LLM OpenAI LangChain demo notebook So just open that one. If you're following through and running on this on your own, just open that notebook. And we'll do some initial configuration or setup, and then we'll go through the whole real demo. So the first thing is to specify your lakeFS endpoint. If you are running locally, you can use, just keep these credentials as is. But if you are using lakeFS Cloud, what you can do is just going to change the endpoint and the credentials. So here, this is my endpoint. So let me copy this. So this is my lakeFS endpoint. And let's create access key and secret key for lakeFS. So if you go to administration and create access key, let's copy this access key here. But if you're running lakeFS local in the local container, you don't have to change anything. Let's copy the secret key. Okay, so that's my lakeFS endpoint and credentials. Now you specify your storage namespace where you are going to create the lakeFS repository. So if you're running lakeFS locally, you don't have to change anything. But if you're running in the lakeFS cloud, as I mentioned earlier, we provide S3 bucket. So let's go here. So this is the bucket we provide. You can use the same bucket to create additional repositories. Only thing, we'll just add the repository name in the as a subfolder within that bucket. So we can use this as a storage namespace. Again, if you want to bring your own S3 bucket, you can do that too. You don't have to, and if you're doing the real POC, don't want to keep your data into a bucket provided by us. You can keep in your S3 bucket and just link into lakeFS Cloud. In lakeFS Cloud, we don't store any data. Data will always stay in your S3 bucket. We just have pointers to those files in your S3 bucket. Next thing is to get the, in this case, I'm going to use OpenAI. So get the OpenAI API key. I signed up for the free account. So you can, if you don't have OpenAI account, you can just sign up. It is free. And then let's create the OpenAI API key so we can communicate through those OpenAI model. So if you go into the creation of the API key, let's create a new API key here. I'm going to call that workshop. Just copy the key here and add this key here in this notebook. Again, all these are variables which will be used further down in the notebook. So assigning those values to those. So let's do this. Then you define the repository name and that you want to create in lakeFS. You can change the repository name or you can leave as is. And then you provide the versioning information here. So in this case, we initially will start with the main branch, main production branch, then we'll create the version 1 and version 2. And in this case, we are going to use this lakeFS brochure, which is our documentation, but you can use any document if you want. If you want, you can bring your own document and just change the document name here, whatever you want to use. In this case, I'm using a PDF document. And we're also going to store the responses in the Delta table. We'll talk more about that. So this document is also part of this sample repository. So it's included here. So if you go here, you'll see version 1 and version 2 document. This is not in the lakeFS repository. This is part of this sample repository. So we have this. So let me just quickly show you how it looks. So it is on my laptop here. So this is basically a lakeFS brochure, information about lakeFS, but you can bring your own documentation. Also, this is my version 1 document. Let's say a few months later, your data document changes. And this is my new document. So you can have multiple versions of the same document. And you can track that in lakeFS and also utilize the functionality of the reproducibility. Okay, so let's set up those variables for version control. Okay, now let's talk about the main thing here, like how you load those version control document from lakeFS to LangChain. So here, this is the function that we are providing here to load those documents. So first you specify your lakeFS endpoint and credentials, which we stored in the variable above. And then you specify your, as I mentioned earlier, you have to add this additional code here, like repository name, and which is also variable, passing into this function, your reference point, which can be a commit ID or the branch name or the tag, and the path where your documents are stored. In this demo workshop, I'm going to use a single document, but you can have multiple documents also inside that path. And then load that document into LangChain. Here, there are some additional things. We are splitting the text and then doing the vector embedding. So using Facebook AI similarity search. So if you want to read more about that, so we are using this as a vector database, and we're doing the similarity search using Facebook AI. But you can use any additional vector databases you want to use. But for this one, we are using this Facebook AI similarity search. Everything is open source version we are using here for this demo, so you don't have to worry about paying for anything. Okay, so let's create that function. Okay, so that was initially how to load the data from lakeFS repository to LangChain using lakeFS document loader for LangChain. The next thing is using LangChain, like how to query your document. So in this case, as I mentioned earlier, we are going to use similarity search. And we want to, in this case, to keep it simple, like 4 similar vectors, but you can increase that also. And then if you are using multiple documents, then you can join those documents together. And next thing, we are going to use this OpenAI model, which is a text, this DaVinci 003 model. And there are different parameters you can change here if you want to. So that's the model we are going to use. Then create the prompt template in LangChain. So where you can specify your input variables. In this case, we are going to ask the questions and provide the document name with document to use. So that's setting up your prompt template. And then create your chain by providing your LLM model, which is OpenAI model, and the prompt template to build your chain and then run the chain. So that's the only code we are using in this workshop. So first you load your document into LangChain, and then you specify your model and then run the chain. So let's create this function also. Okay, let me just quickly check any questions we have in the chat. So far, no. Okay. Let's continue. Next thing I mentioned earlier, I'm going to use delta table to store my responses. Like I'm going to ask the same kind of question with different versions and store the responses in the delta table. So we can look into that in future. But if you want, you can use the LangChain chat history or chat store, where it stores all the responses. But in this case, I'm going to use the delta table. So where I'll specify my storage options here, specifying my lakeFS credentials. So again, the delta table will also be stored in lakeFS. So we'll version control this delta table also. Okay, so next thing is create the lakeFS client. So I'm using this lakeFS SDK library in Python. So let's create the lakeFS client, provide the configuration to connect to the lakeFS server. Next thing, I'm going to create the repository in lakeFS. So right now, if you want, you can create the repository manually from the UI, but here is the code to create the repository. So let's do that. So I'm going to create this repository for LLM. So now if I go back to my UI and just quickly refresh here. So now I have this repository. This is a new repository using this the bucket provided by us just adds a folder path name here. I think I might have made some mistake here. I added, let me create another repo. Looks like I added an extra path here. So let me remove this from the storage. And I'm going to create a new repository. Let's call it workshop. And okay. So let's create a new repository here. So let me refresh this. Okay, so now I have a new repository here, workshop, and storage path looks good. Right now the repository is empty. So next thing what we'll do is bring our document, store in the repository, in lakeFS repository. Let's go back here. So let's start the demo now. So far we just all the setup, create all the functions required, and set up all the variables. So next thing is creating the branch in lakeFS repository. If you want, you can create the branch using the UI. So you can go here and create the branch, or you can do also through the Python API, or if you want to use Java API, you can use that too, or REST API. So create the branch. So what I'm going to do is create a version 1 branch and upload my document. The document I was mentioned earlier, this lakeFS brochure. So I'm going to upload the version 1 document here. And again, this document is included as part of the sample repository. Everything is included here, so you don't have to worry about that. So when I and then commit my changes into lakeFS. So let me just quickly show you how it looks on the lakeFS side. So let me refresh. So I have this version 1 branch here. And now I have this document here, this brochure. And I can look into commit history. Here in the commit, you can add all the words, metadata, as much metadata you want. And also it will tell you what changes happen in that particular commit. In this case, I uploaded this particular document. But if you have lots of documents, it will show you that documents will change, or this, if you are using delta table or something else, what changes happen between those tables. So you can see all those things in commit history. Okay, so next thing is I'm going to call that load document function, which we created earlier to load this brochure into LangChain. So for that, it's going to download some package locally and then load that document, again, using the lakeFS document loader for LangChain to load that document. Here, I'm using the version 1 branch. So I'm loading the document from my repository using version 1 branch, and this is the document or this brochure I'm loading into LangChain. And then for testing purpose, I'm going to ask these 2 questions. Why use lakeFS, and is lakeFS tested by? But if you are using your own document, you can change these questions and then ask these questions. So I'm going to just call this query document, providing the database that we set up here, and then providing the document that I'm going to search, in this case brochure, and asking this particular first questions, why use lakeFS? So this is the response we get from OpenAI using that model. And now let's ask second questions. So why is lakeFS trusted by or not? So this is again these answers are coming from that particular brochure document. And now I'm going to store both the answers in a delta table. You don't have to use delta table, just for demo. You can store this answer in any NoSQL database if you want, or you can use LangChain chat history also is maintained there. So in this case, I just saved both the questions and the answer in my delta table. Next thing, I'm going to commit my changes. So once I commit this, let me just quickly show you how this branch looks like now. So now we got the this document and the responses from those for those questions coming from the LLM model. So all those are saved here in the lakeFS, which so you will have proper versioning as well as the ML reproducibility. You can go back in time. Okay, now we'll merge this data set into main. So you can again merge this branch, particular branch into the main production branch using UI. So basically you compare here two branches. So let's say compare my main branch, main production to version 1. You can see all the changes that happen between those two branches, and you can merge from here, or you can merge through the API. So let's do the merge from here. So that's my version 1 document. So let's say document change over time. And now I want to use the version 2 document. So let's create the version 2 branch and upload the new document, which is version 2 document. As I showed you earlier, these are my two different documents. This is my version 1, and this is my version 2 document. So now this time I'm going to upload version 2 document to my lakeFS repository in version 2 branch, and then commit my changes. And then I'm going to load my document, that version 2 document, into LangChain. So again, just quickly show you how the version 2 branch looks like here. So in this case, version 2 has a new brochure. I just came in just a few seconds back, uploaded. And now we are going to use this version 2 document to ask the questions, same question, those two questions. So again, specifying my document here and the question. And in this case, I'm using version 2 vector database. So ask the same question. And this time it's a different response coming from that version 2 document. Let's ask the second question. And then again, we can save both the answers and the question into my delta table and commit my changes. So now, and if I go back here, I can compare my different branches here. So let's say I want to compare version 1 to version 2 and see what changes happen. Again, the new brochure came in, new document came in, and the responses, we got the new responses also. You can also compare with the main and merge from here, from the UI, or you can merge using the API. So now we merge the version 2 also. So now we can look into the responses coming from version 1 and version 2. So for example, as I mentioned earlier, we save both the responses in the delta table. So you can look into, this was my version 1 document, and these are the answers for these questions from version 1, and these are the answers for version 2. Again, anytime you can go back to any version. Let's say you have hundreds of different versions. You are testing new documents coming in, new data coming in every day. So you might test those same questions again and again just to make sure the model is performing well, and store all that information in lakeFS. So you can, anytime you can reproduce the problems. Let's say, let's say you have some new pricing information coming in as a document, and now you want to compare what was the pricing. If somebody asked about the pricing question, what the response they got 6 months back, and now you can see all the responses, but you can rerun the latest model with your historical data. So you can just specify version number. So when you create your vector embeddings, at that time, just specify the version number here. Or in this case, I'm using the branch name, but you can specify the commit ID. For example, I showed here, you can see the commit ID. So these are the commit ID, which you can just copy in your clipboard. Or if you want, you can create the tag. So anytime you do a commit anything, you can create a tag, let's say version 1 on certain date, or any type of kind of business logic you can add in your tag if you want to. And then you can refer that by tag, your data by tag, and then use that data at that time to rerun your model and ask the same question and see what's the response you get from your recent model. So you can either use the old model and run with the old version of data, or you can take your recent model, run with the old version of data. So that's how you're able to reproduce your responses, reproduce your model response. So that's, let me just quickly look into any questions so far. So one question was, how does the document may integrate into our search and query? Does OpenAI answer based on the document or document similar to that? How does Facebook AI similarity search library may change query results in comparison to not using that? Okay, let's start one by one. So how does the document may integrate into our search and query? So as I showed here earlier, so you can take any document or multiple documents in a path and load that into your vector database and create your embedding and pass that to your model. The second question was, does OpenAI answer based on the document or document similar to that? Yes, in this case, basically, we are running the similarity search here. So you basically take that document, run the similarity search, find the documents which are very similar, and then pass that document or that data set to OpenAI model to provide the answer for that. In this case, I used lakeFS brochure. I'm not using the OpenAI data set. I'm using my own document and passing that to model to get the answer for that. And the next question is, how does Facebook AI similarity search library may change query results in comparison to not using that? So in this case, similarity search will provide better results. You don't have to use the similarity search. You can just take one document and pass it to model to get the answer. But if you use similarity search, it will provide better results. So it will help in that. But you don't have to use the similarity search if you don't want. The similarity search helps more in the fine-tuning your model. Okay, so let me see other question here. I think that pretty much the questions we have so far. Any other questions? We have a few more minutes, like 5 more minutes left. So if you have any other questions, I'm happy to answer that. I hope this was very helpful. Again, all this information is available in our sample repository. So if you want to run this on your own, you can run this and tweak the demo. And you can bring your own document. You don't have to use the lakeFS brochure and then test this, run this demo in your environment. Okay, so let's wait for a couple of more minutes if anybody has any other questions. Let me just quickly go back here while we're still waiting. Let's walk through quickly the difference between the different versions or different options for lakeFS Cloud. As I mentioned earlier, lakeFS Cloud is open source product. We have open core approach, so all the functionality you saw today is available in open source. But in the cloud offering, we provide additional functionality like role-based access control, single sign-on, and other feature set, and in the enterprise edition also. But whatever you saw today, everything is available in the open source version, so you can use open source. And if you want to join our Slack, here is a QR code. lakeFS is trusted by a lot of companies, thousands of users we have in production also. So if you want to join our Slack, if you have any questions, I'm available on Slack, so you can join there if you have any additional questions. Let me see if there's anything else. Any additional questions? Yes, this video, there's a question whether this video will be available. Yes, this video will be available to rewatch. And again, all those instructions are available. You can run everything on your own using our sample repository.